Hi, should I start?
Rajesh, can you hear me?
Yes, I can.
Just to confirm.
Shall we start? 2 minutes is up.
Yeah, just maybe I'll just check if everything is set there.
Hi everyone. Hi Ritesh, can you hear me?
Yes.
Hello.
Yes, we can hear you, Madhumita.
Hi Rajesh. Hi. So hi everyone. Thank you for coming. This is the 14th COMSNETS and the graduate forum session will be starting now. So I'm the one of the co-chair, and you can see here Ritesh, he is the other co-chair. And
Yeah, hi.
hi everyone. So I know Rajesh, Ritesh, you cannot see at the moment, but there are about 12 to 15 people in the room now. As we go on in your session, we will, I think, show the camera to here so that you can also see. Rajesh, is it possible for you to unshare the presentation? Maybe Ritesh will do a very small presentation, introduce, and then we can just go about your presentation. Ritesh, can you?
Yeah. I hope you can see the screen.
Yeah, we can see.
Yeah. Okay, so yeah, welcome everyone for on this graduate forum session. So yeah, so before going ahead, first of all, let me thank Madhumita for being such a wonderful co-chair for this session, and also all the nice papers that we have this year. And thanks, Professor Rajesh, for accepting our invite for giving interesting talk. And we are also having two jury for this session. That is Dr. Rohit and Dr. KP Naveen. So first we'll go ahead with the talk, which is how to write good system papers that will hopefully get accepted. And this talk is by Professor Rajesh. He is an associate professor at Singapore Management University's School of Information Systems, and also director of New Live Labs Urban Lifestyle Innovation Platform. And his main research area is in developing new and novel mobile computing applications. He has several publications, journals, and that's why he's the best person to be on the stage for giving this talk. And I hopefully this presentation will be really great for all the students and the PhD students over here who wants to write and want their paper accepted in top journals. So I'll give the floor first to Professor Rajesh, if you can share your slides, and thereafter we'll continue with the papers.
Thank you, Ritesh. You need to stop sharing.
Yeah.
Okay. Okay, I think you all can see my slides now. The thing is that when my slides are maximized so that it looks good, I can't see the video. So what I've done is I've asked Madhumita to help me convince some of you on the ground to ask questions, right? And Ritesh will ask people online because I plan to make this very interactive. What I'm going to talk to you today is my own personal position on how to write a good systems paper. Now, again, this is my personal position, right? It may be right, it may be wrong, but by talking about it, we understand where we actually want to go. Okay, so don't take all of this as like the gospel, right? This is based on my own experience, and I will actually appreciate it if people speak up and say, look, in my own experience, this is better, things like that, right? Okay, so let's go on because we don't have that much time, right? So a general flow of a systems paper. Now, this is the general flow, right? A systems paper always has a title, as an abstract, intro, background, motivation, some notion about what the system is, some description of how you evaluate it, your sensitivity or small scale evaluations, your larger evaluations, in situ, field, etc. Some discussion, relatable, and conclusion. Now, this is applicable to papers that appear in the SIG Mobile venues, right? Like this are IMWOOD, Mobisys, Mobicom. And generally true for SIG Ops as well, OSDI, SOSP, and probably true for SIGCOM as well. Obviously, there could be small variations depending on the specific type of paper you're doing. In particular, these are all experimental papers, the ones I'm showing, where you actually have results. These are not theory papers. Theory papers will look different. Okay, and I'm not the expert to talk about this. Now, the first question I have, and Madhumita, please pick somebody to ask this question, is of these 9 plus 2 things.
Sorry to interrupt, Rajesh.
Yeah.
We can still see the first slide. So if you can move to the second one, or the screen is
No,
freezed.
the screen is freeze. Do you see 9 numbers?
I see the first slide.
Yeah, Rajesh,
Yeah.
we can just see the first slide. Maybe you
Yeah.
can unshare.
Now it's fine. Now it's.
Yeah, now we can see.
Oh, very interesting.
So now we are on the second
But
slide. Yeah.
it's still not full screen. Is it possible for you to? Yeah.
But when I do it full screen, it looks like it doesn't move. Let's do that again. So what happens if I move to the next slide? Do you see the next slide? Or you're still on the cover page?
On the cover page.
Okay, then fine. Then let's do it this way. Okay, fine. So basically, there's going to be no animations. I can adapt. Okay, so for whatever reason, there's not going to be any animations. Fine. Okay. We will just deal with it. Let me make things as large as I can. Okay, so this is the general flow. The question I wanted to ask is, why is the introduction the most important part? Right? But now I can ask a different question. So maybe somebody in the audience, why is the introduction the most important part of any systems paper?
Anyone like to answer?
Just pick someone, Madhumita. Yeah.
Okay.
Yeah.
In my opinion, introduction introduces the problem, gives a brief introduction about a brief description about the state of the art. Then what is the current paper proposing as a solution, and then summarizes the summary of the.
Correct, but for your paper to get accepted, remember this is about getting a paper accepted at a journal or conference, right? Why is the intro the most important thing? You're actually right. I mean, you're saying what the intro contains, but why is it the most important thing to get your paper accepted or rejected at a conference or journal? It's always the intro.
Okay, Rajesh, I can give you the cynical answer.
Yeah.
Reviewers don't have time. They need a very quick summary and understand why to accept the paper. The intro is the first thing they see, the first impression. So
see, Swarun has gone through this many, many times, so he understands completely. The intro is the first significant part of your paper that reviewers read. Right now, I'm going to come to intro the next slide, but first I'll talk about the good title or abstract. Okay, the title is really important, by the way, because the way conferences work is a lot of papers are submitted and then reviewers have to bid for the papers. The only thing they see when they bid usually is the title. So if your title is catchy with no substance, nobody knows what your paper is about, you'll get random people bidding. If your paper claims the sun and the moon and everything, everyone will bid for it and then they'll be disappointed, right? If your paper claims you're doing X, but it does Y, you get the wrong people bidding for it. So your title needs to be clear. It needs to make it very obvious what your paper is about, because this is what reviewers use to bid for your papers, right? The abstract, sometimes reviewers will use this when they're bidding, but generally they don't because there's too many papers. Reading abstracts take forever. So usually most reviewers just bid based on the title, right? So abstract is important, but by and large, people may or may not may skip this when they're bidding, especially if it's inward, where they literally have 700 papers every cycle. And who's going to read 700 abstracts? Not many people do that. Okay, so a good abstract makes reviewers want to read the intro, but that's all it does, right? Because the intro, as Swarun cynically said, is the first significant part of the paper that reviewers read. And reviewers are humans. They have a lot of papers to review. So they may or may not read your review intro that carefully, which means you also got to make it easy for them to understand what your paper is about. Okay, and I can tell you this from my own experience, reviewers usually decide whether to accept or reject a paper based on the intro. The rest of the paper only reinforces the decision, right? A lot of papers get rejected based on the intro, and very rarely in my own experience in the last 20 years have I changed that opinion after I read the rest of the paper. As in, the intro was so bad, but the rest of the paper saved the paper, that I actually decided to change from reject to accept, right? After I read the intro of all the papers, I have an expectation assigned to the paper, whether it is a accept, possible accept, almost definitely rejected, or I'm not sure, right? Rarely is it not sure, yeah? But usually a good intro is not matched by the rest of the paper. So your paper changes from accept to reject as you read the rest of the paper. But rarely does it change from reject to accept. This is very important. Okay, a bad intro kills a paper. A good intro just continues the process. Is everyone okay with that? Any questions on this? because I suspect a lot of students don't actually realize how important the intro is, because at least from my own experience, when I'm editing with my students, etc., they write the intro last. That's a bad idea to do, right? The intro is the most important part of the paper. It needs to be done first. It needs to be iterated many times. So any questions about this? Anything anybody wants to ask? Because the intro, if you take one message away from this paper, is write a good intro. Yeah, because it's very important. Yeah, go ahead.
You're reiterating that the intro has to be good. So what is a good intro?
Right, that comes next. That comes next. You've asked a very important question, but that comes in the next few slides. What is a good intro? Excellent question, right? A good intro has 5 parts, maybe 6. I can't remember my numbering now. The first part of the intro is some high-level motivation, 1 to 3 sentences. And here, just get to the point quickly, right? Please don't start by saying the internet has changed the world, right? Everybody knows this by now. Right? Don't say no. Mobile phones are the next big thing. Everybody knows this by now, right? So get to the point. What is the high-level motivation for your paper, right? Don't make it. Just use 1 to 3 sentences, and then you need to make it very clear what it is you're actually doing. This is very important. A lot of intros fail because they don't actually say what you're doing. They kind of assume the reviewer knows somehow magically what you're doing, and they go straight into the solution. Right? A solution with no problem is not interesting. You need to make it clear what your problem actually is, right? What are you doing precisely? Why this is important, useful, or groundbreaking? This is key. If your problem is not important, who cares, right? Usually, you might want to have a compelling use case, etc. This is about 1 paragraph, and you need to get to the point and the best bits fast. Don't spend 3-4 paragraphs just going about the problem, etc. Reviewers, if you spend too much time, they lose interest as well. So explain the problem. Why is it important, right? And then you have to explain this part. A lot of papers fail because they do this as well. They don't explain why the problem is hard. Remember, you're trying to get a research paper accepted, right? Research by nature has to be something interesting, something difficult, something groundbreaking, right? So why is this a research paper and not engineering? This is very important, especially for people writing their first systems paper. There is a difference in engineering and research. Right? You can spend a lot of effort building the best Python system, 10,000 lines of code. You will not get it accepted as a research paper because that itself is not a research problem, right? Even though the engineering effort could have taken months, right? You need to explain why it's a research problem, right? And a research problem means you need to put it in perspective, why nobody has solved this before and why solving it is actually important, right? There's lots of problems you could solve that are not important, right? And so you got to explain that. Right? And then the next part is, what is your insight, technique, secret to solve the problem? Give a teaser here. Why is this paper different from all the other papers in this area? Because remember, very few things are truly novel. Every area has had somebody doing it before. So you got to explain why your solution is more interesting than what has already come out before. Okay, and here's where you give a teaser of your insights, etc. Then you do a summary of your key and most impressive results. Again, about 1 to 2 paragraphs. Right? And then your key contributions. Very important. And this is where you have to be very clear, because a lot of reviewers use this as some kind of checklist for your paper. As in, they'll actually look at this and go, this is good, oh, I don't believe this. And if your contributions don't actually match the rest of your paper, you'll get rejected. I see a lot of papers where they claim, oh, we tested thousands of users, and then you learn the thousands were simulated. That just leaves a bad taste in your mouth, right? And you learn they only tested with 3 real users, right? But the intro, the abstract says they tested with thousands of users. So don't lie, okay? But at the same time, also, there's a way to spin your results without lying in a good way. Okay, then the rest of the paper, I'm going to go faster because we only have half an hour, so I want to end in like 15 minutes. We started a little late. Background motivation, the rest of the paper, background motivation. This is important if your area is not that well known. System, describe what you built. Again, I'm not going to belabor the point. The slides will be given to you, and you can contact me if you have any questions. Remember, system is where you talk about the interesting parts. Don't spend lots and lots of effort talking about engineering. Your XML schemas, your programming may have been important. Don't spend 3 pages describing it, because most reviewers are not going to care, right? They all understand the effort needed. Unfortunately, the effort needed is kind of taken for granted in a systems paper. Yeah, unless the engineering involves solving a hard research problem. Okay, this is the sad truth. Evaluation methodology. This is often overlooked by many writers. You just go straight into the evaluation without telling how you actually did it. a good evaluation needs to be clear to the reviewers, and most reviewers will not take your evaluation as real unless they actually understand how you did it, which means you need to talk about your methodology and convince them that you did it in a scientifically sound way, right? This includes making sure you have all the IRBs. If you're doing user studies, you explain how your data was collected, you explain how your data was cleaned, things like that. Okay, and then many systems papers start with small scale experiments that show the sensitivity, the system working in small scale with different control studies. And you've got to show the corner case and other sensitivity results. Don't just show the bad case, reviewers will catch it. This is again true for the top conferences, right? You have to show the corner cases and the cases that it might break, just to convince the reviewer you understand how your system works. It's okay to have a few cases where it breaks as long as they're not fatal, by the way. Yeah, and then finally, for top conferences, you also need larger scale real-world experiments, right? Simulation-only papers are rarely, if any, accepted at any SIG Mobile top venue, SIGCOM or SIGOPS these days. You need to have something real, right? Unless it's an area where there is no real implementation. Then you might be able to get away with a simulation, right? Maybe, but those are really hard. Make sure you have sufficient user duration samples. This is very important. The big hot thing today is DNNs. But remember, to train a DNN, you literally need thousands of data points, not even hundreds, thousands, right? And so if you're collecting data from 10 users and you're using a DNN, most reviewers these days will just roll their eyes and go, yeah, that's overfitting. Okay, so the days when you can just put DNNs in and expect people to believe your results will be better are gone, right? At least at the top venues. So you got to use DNNs with a purpose. Otherwise, the simpler techniques like decision trees, etc., all work really well still. Okay. Then have a discussion, explaining the larger implications. This is not that important, but you should have some discussion of putting your work into perspective. And this is where you can talk about things that break your system or you haven't covered, but you can at least talk about it, right? So the reviewers will at least say, okay, you understand, right? And then related work. Related work is important just to point out to the reviewers that you understand where your work falls in relation to prior work. Okay, there's 2 things in related work you must have. You need to have all the most important work. Otherwise, the reviewers immediately believe that you don't understand the area. And you should also cite work of likely reviewers. This is tricky, but you've got to make sure you cite the work of likely reviewers, right? So check the PC before submitting. Top venues, the PC are the ones to read the paper. So please check and at least cite their work, right? A very good way to get your paper rejected is not to cite related work by the PC. It's a bit unfair, but that's the way it is. Right? Usually related works end of the paper unless you're in a really, really well-known area like Wi-Fi indoor localization. Then you put it up front and tell them, make it clear why you're doing something different. Okay? And finally, conclusions. A lot of reviewers read this after the abstract, but this is where they're just getting some insight into your paper. They're not making any big decisions yet. That comes after your intro. Right? So your conclusion and abstract are just to get people excited to read your intro, right? Just get them more and more excited. Okay, any questions up to now? Anything y'all want to know? Because after this, I'm going to skip gears about the paper structure and talk very quickly about how papers actually get accepted at conferences. I'm going to demystify the black box a little bit. Yeah, because the way papers get accepted at conferences is reviewers read it and then there's a meeting. This meeting can be online or it can be face-to-face for the top venues, and then the papers are discussed. And they get accepted or rejected based on the discussion. I will try to demystify some of this based on my own experience as both a program committee member and a program chair previously. Questions? Okay, let me go on then. So common rejection reasons, right? Why do papers get rejected? One of the most, and these are things you can fix. So the reasons, obviously there's a lot of variability in the process where papers get rejected just because somebody was grumpy, etc. Unfortunately, those happen. You can't fix that. These are the things you can fix, which is why I'm talking about them. The first thing is always spell check your paper. Now, English is hard, right? I mean, grammar is hard. Most people do not speak English as a first language. We understand this, but there's no excuse not to use a spell checker, right? I've had papers where the title was misspelled. I can assure you those papers were never accepted. They never made it past the first round. Yeah, because if you misspelled the title, that's just unacceptable, right? So please use a spell checker. Yeah. If you can get a good English writer to at least read your intro, right? This is hard, but at least try to do it. Okay, because if people don't understand, unfortunately, your paper cannot be accepted, right? This is not easy and requires a lot of time. And I understand the last minute rush to write papers, but try to get somebody who's a good English writer who may not necessarily be good speaker. Good speakers and good writers are different. right? Get a good writer to at least check your intro. Okay, and this is the priority I would put them in my own opinion, right? The easiest sections to write are related work and the results, because results are mostly numbers, right? And related work, you're just talking about past work. The hardest is the intro. Okay. Have clear and legible figures. You'll be surprised how many papers have, they try and cram everything to the page limit, and they have pictures that are so tiny that even when I blow it up in PDF, I can't figure out the words or the lines. I'm sure Sarun has seen this so many times as well. And if we can't read your figures, even when blow it up, there's no way your paper is getting accepted, right? Absolutely not. Legends and axes must be large and clear. Explain figures. See, these were animated, so unfortunately that's gone. But we see things like, as you can see, we do well with nothing further. Reviewers will just assume the figure is wrong, or without loss of generality. When it's not clear why it's without loss of generality, we assume it has scalability issues. Or the best one, interest or space, X is omitted. Then we just mean that X, there's no X actually, right? Because it's up to you to decide what to put in the paper. If you didn't want to put it in, it's not important. Right? That's the reality of it. Every conference has a page limit. If you chose not to put it in, it means it's not important. But the fact you're telling us about it, but not putting it in, what's the point, right? Reviewers kind of understand this as well. Okay, experimental setup must be clear. I've already mentioned this. Systems experiments need to be clear as well. You can go read this later. The slides will be provided to you, right? If for those of you doing user studies, it's very easy to get a paper rejected if you have a user study and you don't explain how your participants were recruited, right? It's so easy to mess up a user study by biasing your participants, etc. If you have questions about doing user studies, etc., please ask people who've done it before, right? If you don't have anyone, you can always ask me. I've done a lot of them, right? They have a particular style. If you have error bars, please provide error bars and explain outliers and results. If you have an outline in the result, please don't assume people will ignore it. Most reviewers will just focus in directly on the outlier and ask what's going on here, right? And if you haven't explained it, they'll be wondering why you have not explained it as well. Any questions up to now? Anything anybody wants to know, right? Swarin, you okay with all this? This makes sense?
Yeah.
Anything you want to add? Especially, I know, especially about illegible figures, right? This is so common in networking papers, sadly.
Yeah, I agree. I think I'd also add that a lot of these problems, I think Rajesh's most important point is the importance of the intro here, right? So if we see any of these problems at the intro, right, that is much more severe, right, than it showing up in other pieces of the paper. One small figure somewhere deep in the paper is not going to make a big difference, but your intro picture, right, or your key result, right, being unclear can be terrible.
One small figure is usually not a problem, but unfortunately, a lot of networking papers, all the figures look like that because they use the same broken MATLAB template or etc., right? And you're trying to squeeze everything. We can't see any of your results. Yeah, the paper's not getting accepted, right? The key is not to put as many results as you can. It's to put your best results and explain them, right? That is very important. It's very hard to get over the mentality I need to dump everything to I need to only put what is important, right? So instead of having 8 figures that can't be read, put 5 and make all of them legible, right? And explain them. That makes your paper much more likely to be accepted. Yeah.
Rajesh, there's one more question online by Sapna Chaudhary. She's a PhD scholar at IIITD. So her question is that we read a lot of related papers. So what we should keep in mind while putting those papers together?
I don't understand the question, Sapna. This is about writing a paper. You mean how do you mention related papers? Yeah,
so
in related work, at least for conference papers, you should not explain the related work too long. This is not your thesis. Remember, you have a page limit, so I would just put everything together, and you could say something like, there's been a lot of work in indoor localization, and put like 5 citations there, right? Always look for the best citation. So instead of citing 10 papers, cite a survey paper that lists all of them, a good survey paper, right? You always want to find the most minimal way to get the point across, because the longer your related work, the less you have for your work. Remember, related work is not your work. It is somebody else's work. So don't try to minimize the amount of content you have in related work, right? But it's important to put enough content there that the reviewers understand the related work. Okay? Yeah.
Yep, thank you.
Yeah. One very important thing that reviewers that always get into trouble they find with papers is the papers assume domain expertise of the reviewers. Never assume that, okay? Assume your reviewers are top PC members if you submit into a conference and they're all smart people, but don't assume they're experts, right? So don't leave out information that only experts will know, because that's a great way to get your paper rejected, especially if you're doing things that require them to know something about the country. I see so many papers coming from developing countries like, Bangladesh, India, etc., that assume reviewers understand the situation in India and Bangladesh, etc. They don't. And then they'll have no idea why the world looks like this, because they'll compare to their own situations in the US or Europe and go, the world doesn't work like this. Let's reject the paper, right? So you got to explain, you got to spend the time to explain why the world is like this and why this problem is important, right? You need to set a common understanding where needed. Okay, it's particularly important for problems. India has a lot of problems that are specific to India, and solving them is important. But when you write a paper, you got to explain why this is important and why this is India specific. Okay, I hope that's important, especially networking, because there's so many networking problems that make sense in India, but not in the US, for example. Right, so if you submit to Infocom, Mobicom, etc., the reviewers will put a European, Asian, or American hat on and won't understand why this problem is important. Okay. Now I'm going to finish in like 2 minutes. Why papers get rejected at PC meetings? Number one reason is because nobody championed them. You need to find a way to get somebody to stand up and say, I want this paper accepted. Sorry, I'm starting to cough. Right? One person saying, I want this paper accepted trumps as many other people saying, I don't really like this paper. On the other hand, one person saying, I hate this paper trumps almost anyone else saying, I want this paper. Right? If one person finds major flaws in your paper, it's very likely your paper is getting rejected, because nobody wants to take a paper that's fundamentally, that's possibly flawed. Okay, and these tend to be experts, by the way. Experts tend to be brutal in their reviews. So if you are getting an expert to review a paper, make sure you've done everything properly. Okay, and usually the main result to reject a paper is because the results don't match the promises in the introduction. Remember that contribution I told you about? The rest of your paper needs to match that, because reviewers hold that as a promise, right? So you say, no, we'll show we have 20% improvement. Then deep inside your paper, it's actually only a 5% improvement. Yeah, your paper is getting rejected. Okay, because you didn't match your promise. Okay, so the main takeaways, because we are out of time. Good descriptive title, excellent introduction. This is key, right? This is very important. As Swarun said, reviewers have way too many papers, and this is the only thing that you're guaranteed that they will actually read, at least to some level, right? The rest of the paper, they don't like your intro, they may just skim it. And that you will actually know this when you see the reviews, right? Test your solution comprehensively in small and large scales and provide all your key error results. Okay, and that's basically what I wanted to cover, a quick and hopefully useful insight into how the reviewer process works from the reviewer's perspective, right? Which a lot of you may not have actually got previously. Yeah, there's some things here that I suspect a lot of you have not seen before. So, okay, I see a question. For a person coming with theory background and limited experience writing system papers, what are some pitfalls? This is actually a very interesting question. So one of my students has a pure theory background, right? So he tends to go into very low-level details about algorithms, etc., which are details, right? Details, at some level when you write a systems paper, what matters at the end is performance of the system. It's not the performance of any particular component, unless the component is really important. Whereas for a theory paper, the components tend to be really important because those are the algorithms, the proofs, etc. Right? For a systems paper, the proofs, etc., are not the key part. It's actually the working of the entire system, whatever the goal of the system is, right? So you got to take yourself out from from just showing the proof and the theorem works to showing the entire system works. And part of that could be showing a particular theorem works if it's a key theorem, but you need to show the entire system working. Right. The question, Swarun, if you have any insights, is for a person coming with a theory background and with limited experience writing systems papers, what are some pitfalls one should consciously be aware of or avoid when writing a systems paper?
It's actually interesting because my undergrad was mostly theory. So I can say I came from a theory background and sort of moved into systems for my PhD. Short answer, I would say, is it's kind of similar to your student's experience, Rajesh. as a theoretician, you write your papers for the experts. Your papers, the introductions tend to be much more detailed and focused. Assume the expertise of the reviewer, because it's a small clique effectively for when you think about reviewers for theory papers, especially in a given area. Systems is quite different. The reviewers are very broad, interdisciplinary. So when I read the first systems paper, right, that my advisor emailed me, right, her paper, I first found how remarkable it was. I was totally, I didn't work in that area, but I could understand it, right? It's so easy to read and understand. And that's true for all good systems papers. So I think that's a key difference. So think about pitching your paper to a broader audience. Look at your paper from 10,000 feet, right, and try and present the bigger picture. Make it easy to read and understand, and also have a very strong evaluation, right? I think it's not just about. I know it's all. Rajesh mentioned a lot of common pitfalls, but one thing one bullet that he had that is underappreciated is the amount of evaluation that's needed in a high quality conference. So aim high and do that robust evaluation.
Let me push back on that. I didn't want to mention that too much because I didn't want to scare you. Mobicom or a Mobisys paper is usually submitted for 12 pages. Anyone in the room other than Swarun, how many pages are usually evaluations for a 12-page Mobisys submission? Madhubita, pick someone. How many pages do you think will be evaluation?
How many pages are
In evaluation.
Out of 12 pages that are submitted?
maybe I'd say 2 to 3.
Oh man, at least 7. Did you hear my answer? At least 7 of those 12 pages will have evaluation results for a Mobisys or Mobicom paper. Yeah, sometimes up to 10. I've seen papers which had 10 pages of evaluation. They just get straight to the point, right? And they just evaluate like crazy. I think Swarun knows exactly what I'm talking about. Usually, at least the minimum I've seen is 6. Usually, it's 7 or 8 pages of evaluations. I just submitted 2 Mobisys papers. One had 7, the other had 7.5 pages of evaluations, maybe 8. Yeah, that's the bar expected on evaluation, by the way, in the top conferences. SIGCOMM is similar. Any questions from the room before we end? Because I know we are running a little late.
In some conferences, there are rebuttals. So
Yep.
how important it is to kind of give it your all for a rebuttal? And what chances are there for?
It depends. The only answer I can say is it depends, right? There are rebuttals and there are rebuttals. Conferences, they have rebuttals. I mean, when you look at the reviews that come back, you can kind of get a sense of whether your rebuttal will matter or not, right? In many cases, it does not, because the reviewers have already made up their mind, right? In some cases, it does, because they misunderstood something key and you can help them explain. In all cases, your rebuttal should be polite, right? I know, and this takes a bit of experience, right? I know that sometimes the reviewers don't read the papers properly, they write rubbish, and you might feel the need to vent in your rebuttals. Please don't do that, because they will remember who you are, and it's not professional, even though you may not know who the reviewers are, right? And there's people on the side. So just, even if you don't agree with them, just be polite and submit. But in many cases, rebuttals are just going through the motions, to be honest. In some cases, it matters, right? Because this is particularly true for journals, etc., like Inwood, etc., where you have a reject and major revision. In that case, it matters a lot. But for conferences like CSW or CSCW or CHI, where they have rebuttals, for many cases, I think 60-70% rebuttals don't matter. Paper status does not change. For the remaining 20-30%, yeah, it can make a difference. Okay, but in all cases, please be polite in your rebuttals, right? You don't really want to antagonize people without meaning it, right?
So another question. You said that the introduction is the most important part, yet in the later part, you are almost stressing that top conference paper means solid evaluation. So,
Yep.
So which is more important?
Well, the solid evaluation is spread over 7 pages. And that is actually to validate whatever you put in the intro. The intro is only 1.5 pages. That is the first thing the reviewer reads. And they make up their mind based on that. The remaining 7-8 pages of evaluation is to validate what you said in the intro, by the way. So that is why most papers get rejected, even though the intro is excellent, because the evaluation is not at the level that the intro actually states. Does that make sense? So the intro just makes sure that the process continues. But if your intro is bad, the process does not continue. Your paper is rejected there and then. Okay? Because remember, you have 7-8 pages evaluation. It's okay to mess up one graph, at least not fatally, you know. It's okay to have a result that's not great. Whereas intro is short and to the point. If you mix up any of the things in the intro, it can have major consequences because you don't have a lot of space there, right?
Thank you, Rajesh. I think that is all the questions from the floor. Ritesh, is there any question in the question answer?
No more questions. But Rajesh, one thing, as a reviewer, sometimes we see that there's a lot of contributions mentioned in the introduction or in the abstract, but when we map in with the conclusion, then actually it's not particularly mapped. So it's not all the things that are covered in the paper. How do you see that?
Well, that's this point. That's this most important point here. Where did I mention it?
Sometimes it's like overselling paper, and then at the conclusion you see that there's.
Oh, I'm sure I
yeah.
put it here. Common rejection reasons. Right here.
Yeah.
Right here. This is the most important reason why a paper gets rejected. Right? It's right at the bottom. And it's exactly what you mentioned. The intro promises the sun, the moon, the universe. The rest of the paper only delivers a small bus stop in some small country somewhere.
Yeah, indeed.
Okay. This is very important, as Ritesh pointed out. I may have not, I thought I said this, but I'll say it again, right? Your intro has to match the rest of the paper, right? It's a fine balance between exaggeration and underplaying. You can't underplay because then people won't get excited, but you can't exaggerate either because then your paper gets rejected.
Yeah, thanks, Rajesh. So I think there's no more questions online and on the floor as well. Madhumita, we don't have any.
Ritesh, actually, we do have one more question.
Yeah, sure, we can take up. Yeah.
What's your name, by the way? You've asked a lot of very interesting questions.
My name is Himanshu Gandhi. I'm from IIT Delhi.
Okay, hi. Who do you work with?
I had a question where how do you identify whether a paper has readability issues in terms of the reviews talked about, say, I'm taking an example where from a rejection where they said we are not able to find this in the paper, you haven't compared with this work, and so on and so forth. And then there was a comment that this proof is not right. The friend whose review was I was reading, I felt that they had readability issues where I couldn't, the reviewer was not able to find out the various works that he was looking for, whereas she focused on some of the proofs that the paper didn't probably.
Yeah, unfortunately, there's only one answer for this, which is to get your paper read by other people. Unfortunately, it's very easy to not have your paper read by anyone other than your actual authors before submitting because they're all rushing for deadlines. So we don't actually see the paper read by different people. Reviewers have no bias, so they read it from a different light, and the only way you'll see that is to get your paper read by other people, right? So after the first rejection, etc., after you write the paper, give it to somebody else in your department, another student in a different area. Ask them to read it, right? Use all your friend networks. Just ask them to read it. Or ask them to read the part that you're not sure about. And they will tell you bluntly whether it's readable or whether your proofs are correct, as far as they know. Okay.
Hello. Hi, Rajesh. This is Shiv from IIT Hyderabad. Actually, my question is regarding the accommodating reviews, like especially at the last moment, like how important to accommodate reviews and like how to prioritize or decide which reviews that we are going to accommodate, like especially in the last rush.
What do you mean reviews? So this is a paper that has had reviews before, and you're submitting
Like
somewhere else?
it's like other way around. Like it's not about the reviewers. Like as a candidate, suppose I submit a paper and I got few reviews, and some of might take a lot of time to accommodate them in the paper.
This
right?
is unfortunately this comes with experience, right? So I would suggest
okay.
ask your advisor. If your advisor can't help you, ask someone else. If they can't help you, this is why you come to COMSNETS. Ask me, ping me out the blue. Ask Ritesh, ask Madhumita, ask Swarun. Come to us early, explain the thing, and we have time to help you, right? Unfortunately, this comes with experience, figuring out which reviews are correct and which reviews are not correct. Getting reviews is easy. Getting good reviews is really hard. Yeah, so you have to be able to separate them as well.
So I guess that's about it. I think we should wrap up. Rajesh, thank you so much. Everyone, if you have any more questions, please email Rajesh Catch. He's generally quick to reply. So please, thank you so much, Ritesh. Up to you.
Yeah, thanks a lot. It was really interesting to hear about all your experience, Rajesh, and thanks for all the inputs of the paper, like paper structure, importance of introduction, conclusion, most important, and thanks for sharing your time. And also, I would like to thank Sarun for making this session interactive and giving his inputs. Yeah, thanks, Sarun. So, Madhumita, maybe we can go ahead with the papers.
Yeah, Ritesh, maybe if you will stop sharing, we'll just start in a second. So the next talk is by Apurva. It's going to be a physical talk. So Apurva, can you please come on?
Can I take off my mask while talking? Hello, this is Apurva Kulkarni from IIIT Bangalore, a PhD research scholar. So we at IIIT Bangalore at Minro Labs, we are working on the heterogeneous data. I'm over here to present a talk about CDEF, that is Conceptual Data Extraction Framework for Heterogeneous Data. Before I dive into the technical discussion, I would like to address a real world problem which is very much relevant to the work that I'm going to present. The possible approaches and the limitations that we are trying to address. And then I would like to conclude on a promising note where I will be discussing the proposed architecture and the components of the proposed architecture. Okay, so in the domain of big data, when we are having a proliferous amount of data being generated, the two virtues are very important to talk about. One is the volume and another one is the variety. The HDFS platforms, the Hadoop ecosystem gives us features so that we can deal with the big volume of data. But when we are trying to address the variety aspect of data, it is very much important to establish the linkage between them so that we can fire a query across different data sources. So let's consider a real world problem. Our office is at location which is mentioned over there with a lat long value. And if we want to reach to destination Silk Board, now we have the information, the entire transportation information available with us. Now to break down our problem into smaller chunk, um, so first we need to find out the bus stop possible, like reachable from our lat long value. The second would be what are the bus routes available from that particular bus stop. Then we need to filter out which are the bus routes which are leading me to Silk Board. And then according to the current time scenario, I need to choose the possible bus route. Considering this entire subset of problem, when I try to map it to databases, uh, uh, let's say like each subset of the problem is getting mapped to different data sources, and these data sources can be of similar type or it can be of different type. So when the data sources are of similar type, we can say it's a homogeneous data. But when there is a slight deviation in the similarity domain, it counts to be a heterogeneous data. So the homogeneous data, that means similar features, we can observe in the terms of data format, data model, the originality, that means the data source which is generating the data, and the temporal heterogeneity means in the time zone or the time granularity that we are considering to generate the data. Any slight deviation in the similarity generates the heterogeneity in the data. There are two possible approaches to deal or to address the heterogeneity, and those are, we can process the heterogeneous data in the integration of data approach, and another one would be processing the heterogeneous data in the federated environment. When we are talking about generate like processing the data in the integration of data approach, it is similar to the traditional ETL process, where we are extracting the data, transforming it to a common form, and then we are loading it for the further processing. When we are trying to transform a data into a common like a unified format, it leads to following limitation. The one is data privacy. When we have individual data sources, it is easy to maintain the privacy or credentiality of data. When we are bringing all of the data into a common platform, it becomes very difficult to maintain the the security aspect of data. Another problem is assuming in a big data environment our original data sources are available in X format, and after transformation we are expecting them to be in particular Y format. So if the original data size of 100 TB, then again we are duplicating it another format, and again we are actually consuming the another 100 TB of data. And when we are trying to convert it to one unified format, which format we should choose, and what would be the mapping scenario when we're trying to map individual data source to a required one, is a challenging task. This leads us to like throw some more light on the another approach, that is, when we are trying to process data into a federated environment, we are keeping data as it is, but we are making the query processing or data access in more intelligent way. This is possible by having a middleware which will communicate or facilitate the access to individual data sources. Uh, when we are trying to choose a middleware, programming that middleware and providing one-to-one mapping with the existing data sources is a challenging task. Another thing is to reduce the travel cost to the individual data sources. If we are trying to fetch more data, then we need to crawl it at the user end. That would be another headache. If we try to ask exact what data we want, like having an underfetching problem, then we would need to travel again and again to the federated data source to fetch the information. One more disadvantage is if we try adding new data sources in the federated environment or middleware architecture that we're developing to facilitate the communication with data sources, the programming overhead keeps increasing. So as we keep on increasing the data sources, the communication task increases on that. So considering all of this limitations, we are proposing a conceptual framework, that is the CDEF. What we are trying to do over here is, on a overview, if we have X TB of information and we need to process only Y TB, the subset of that, but the information is distributed across different data sources. Once we have the important information, we can like push that information on HDFS platform for parallel processing. But how to get the Y information, which is a subset of XTB information across different heterogeneous data sources, is what we are trying to address. This gives us to baseline to set the objectives. So when we are talking about conceptual data extraction framework, the concept is nothing but the facts which we are trying to fetch from the individual data source. We are clubbing those facts together and the metadata information and generating a local schema. Individual local schema of the data sources are then stitched together to form a global schema. This global schema is then further used to process the query and then provide the access to individual data sources. So on the architectural perspective, we are dealing with the two processes. One is the static process and the dynamic process. Static process is responsible for accessing the heterogeneous data sources and generate the reference documents. One doubt, can you read the components? It's blurry. Yeah, can you do next? Go to the next slide. This is more better. Yeah, okay. So in this diagram also we are having all the components which I was discussing in the architecture. So I will consider this as my reference diagram. So over here we are dealing with the two layers, the conceptual layer and the orchestration layer. The conceptual layer is responsible for generating the local schema. That is, a conceptualizer will access the individual data source and generate the schema and a data adapter. All these schemas are then collected together, given to the schema linker, which will link them together and generate a reference documents called as a global schema. This global schema is then provided to the query mapper. The input query, when it is fired on a distributed query on a distributed data sources, the query decomposer makes the query simplified. With the help of query mapper and access path generator, it facilitates access to individual data sources. The output from individual data sources are collected and given to the output synthesizer, which generates the final output. To understand flow in a more detail, so there are two flows. The first one is the data sources given to the conceptualizer, generating schema and the data adapter. The schemas are then given to the linker, generates the global reference document as a global schema. This reference document is given to the query mapper. When we are firing an input query, it goes to the query decomposer, which generates the simple query, which is then fired on an individual data source. These simple queries, with the help of global schema, query mapper and the access path generator, facilitates access to individual data source. Output from the individual data sources are collected, given to the output synthesizer, and final output is being generated. Now this is a white paper that we have that I have proposed, and we are still implementing, so I couldn't propose the results over here. But the key challenges that we are trying to address in the entire implementation task are okay. Identifying the baseline data sources and the data models to propose and implement the architecture. Then defining the semantic mapper. So when we are generating the global schema, what are the different, what would be the different strategies to generate the global schema? And optimization strategies to generate global schema. And again, defining the parameters. So once the architecture is ready and we have implemented it, what should be the parameters to judge the performance of the proposed architecture? These are the key challenges we are working on and the key references. Thank you so much. I'm open to the questions.
So do we have any questions?
How different is your orchestration layer different from the Hadoop map reduce kind of a framework, which is kind of so old that it is, I think it was already deprecated in 2018 or so, and it has been replaced by other frameworks. So those kind of frameworks are already there. So how is your orchestration layer, and what additional things you are doing above those commercial schemes?
So once we know the subset of data which we want to process in parallel processing, then we are pushing it to Hadoop platform. So but when our data sources are different, and which are actually, like for example, one data sources from one organization and other data sources from other organization, in that scenario, like establishing the linkage between them and then extracting. So as CDEF, it is not querying platform, it is an extraction platform. So when we are having different data sources and we have to grab a chunk of data together for further processing, this task, so before we push data to HDFS, we need some chunk of data that we will push to HDFS for parallel processing. To how to reach to that level where we can fetch data from different data sources is what we are trying to address. So the parallel processing by the query engines given by Hadoop, which allows us to query along with the different platforms, are when once we have a data on Hadoop, then it tries to give us access to process it. But as I was trying to explain, like if I have x TB of information, but I need only y TB of information for further processing, then how to extract that important y TB of information across different data sources from various organizations is that we are trying to address.
Okay, if you have no questions, I think thank you, Apurva.
So
Oh, sorry.
Can you have the slides on, please?
yeah.
So my query was related to your privacy or duplication challenge that you had talked about. So, considering that there are okay, let
Yeah,
me sum
it's
up.
fine. Like I understood. Like when I'm talking about the integrating it together, so
Yeah.
the first challenge which I talked about the data privacy. So at the
Yeah.
individual, so can
Yeah.
you please?
So for privacy, like there, when there are different bridging strategies available in literature, which obtain data from different such data sources and bridge them together into a single data source. So they either do that using using encryption on the obvious option, or if now encryption is used when there is no trust available, but if there is trust between the different data sources, then you could just collect it and create a homogeneous framework. So can't the privacy aspect be addressed using any of these two? Because in that way, uh, the major key challenge that you have for that framework is removed. So why isn't that an option then?
Yeah, actually I don't have much knowledge about the security domain, but as I have understood your problem, if we have encrypted data that we have kept in the like the main storage after the transforming, while querying that data, we need to consider the understanding the query processing should understand the encrypted data, and then it should be able to query it, right?
You will have decryption frameworks on the
So in the
client.
real time domain, when we are trying to query data on like a faster way, uh,
No,
like
that's
I'm just,
even available for real time. Maybe you could look into that
I'll look
area.
into it, sir.
And there's you could also look into, if I mean, if you're not going into the security aspect, but there's this area of homomorphic encryption.
Can you repeat?
I'll give you the name later. So what it does, it just extracts any important information from the data that is arriving. You don't need to decrypt the data, but it will just
Take a
take
subset
a
of.
subset of. So maybe you could try
Yes,
to
yes,
look into
yes, sir, yes, sir.
rest it's fine. One comment I had for some of the slides is there was too much text,
Okay.
which you could have replaced with either
the-
flowcharts or diagrams for easier for the house to understand. Thank you.
Okay, thank you so much, sir.
So next speaker, Manideep, can you please come in? Yeah.
Hello, I'm Manideep. I'm a fifth year student in a dual degree bachelor's plus master's program at IIT Kharagpur. I've been working on a topic for a while on my master's and bachelor's thesis. It is on unconditionally secure commitment over unreliable noisy channels. Before I talk about that, I'd like to thank my supervisor, Professor Amitalok, and other collaborators, Anuj, Pranav, and Professor Manoj. Okay, I'll first introduce you to the commitment problem with the help of a coin toss example. In a traditional coin toss, there are two players. There is a tosser and a guesser. The tosser tosses the coin into the air, and a guesser guesses the outcome. Accordingly, a winner is decided, supposedly uniform at random. But if the guesser was sophisticated enough to predict the toss outcome from the coin trajectory alone, he would always win. And that defeats the purpose of coin toss. Now, a commitment protocol is an alternate scheme which offers a similar desired functionality. In a commitment protocol, we have two parties, a committer and a verifier. The protocol happens in two phases. In the first phase, the commit phase, a committer commits to a choice but doesn't reveal it to the verifier. Only in the second phase, the reveal phase, he reveals the choice which the verifier later verifies. This is a simple functionality, and this finds widespread cryptographic applications. The earliest forms of commitment were realized noiselessly and were secure only under certain computational assumptions. Later, it was found by the community that certain noisy channels can be used as a resource to realize commitment with unconditional security. And in our work and some other earlier works, this has been the main focus of work. This is a rough idea of the problem setup of commitment over noisy channels. We have a committer Alice and a verifier Bob. They share a one-way noisy channel that goes from Alice to Bob and a two-way noiseless link. Alice starts with a commit string C, which she wants to commit to, and she encrypts it as a code word and passes it over the noisy channel, and Bob receives a noisy version. They meanwhile also exchange a series of messages over the noiseless link. And that concludes the commit phase, at the end of which Bob is to be totally oblivious of what Alice's string C was. Now, only in the second phase now, the reveal phase, Alice is going to reveal her commit string C. She's going to pass a string C tilde over the noiseless link to Bob. Now note that this revealed string C tilde may or may not be equal to the actual C. So Bob will perform a test to check if C is actually equal to C tilde. Accordingly, he'll either accept or reject. Now this is a commitment protocol, and it has three key security objectives. They are soundness, concealment, and bindingness. Soundness says that the protocol works for honest behavior of Alice and Bob. In other words, an honest Alice should always accept an honest Bob should always accept an honest Alice's string. Now, concealment says that if uh, Alice was honest, no malicious action of Bob will help him peep into Alice's string before the reveal phase. Now, bindingness analogously talks about the case when Alice is malicious but Bob is honest. A malicious Alice will try to confuse Bob by revealing a string that is different from what she has committed to. Bindingness ensures that that just cannot happen. Note that we don't offer any security guarantee when both Alice and Bob are dishonest or malicious. Now, yeah, this is so far I've discussed commitment protocol over any given simple, any general noisy channel. So now I'll talk about a class of unreliable noisy channels and its significance. So we know a classic binary symmetric channel. A BSCP is a channel which flips zeros and ones with crossover probability P. Say imagine a case when this crossover probability P is not precisely known, or a malicious party could be controlling this crossover probability. We model these unreliabilities in the form of this unreliability noisy channel model. So we have three parameters here. We have S, SA, and SB. They are subintervals. They are continuous subintervals in between 0 and half. So S denotes the range of crossover probability values that get instantiated when both Alice and Bob are honest. Now, but if Alice was malicious, she could she could fix the crossover probability to some fixed value in the range SA, capital SA. And similarly, if Bob was malicious, he could do the same by fixing the crossover probability in the set SB. Now, using this model, we could look at some unreliable channel models. Here, these are four such unreliable channel models that have been studied earlier, and some which have been part of our work. First is a compound channel. It models a form of unreliability called compoundness. Uh, so then we have elastic channels. They model these elastic channels and reverse elastic channels. They model the elasticity form of unreliability. In an elastic channel, if Alice and Bob both were honest, BSC delta gets instantiated. But if Bob was malicious, he could bring down the error probability to gamma. And then we have I have a fourth channel model, and the unfair noisy channel, which models the combined form of unreliability of both the compoundness as well as the elasticity. So we have from some of the earlier works, Krupu et al. Found the commitment capacity of these unfair noisy channels, and Kurana et al. Found the capacity expression for the elastic channels. By the way, in our work and these works, the focus has been to characterize the fundamental limits of commitment by the commitment capacity. And here we complete the picture by finding the commitment capacity of the remaining two channels, the compound channels as well as the reverse elastic channels. And these are the expression. And we can note that the commitment capacity of compound channel equals that of the elastic channel. And there are some key observations that we can make here, a couple of points actually. So first one is the, also here I've plotted the commitment capacities of all the four channels along with the BSC delta channel. So we can see that the commitment capacity of the unreliable channels is always less than that of the BSC delta channel. And another thing to note is that the commitment capacity of the reverse elastic channel is always less than that of the elastic channel. So it looks like a malicious Alice is able to bring down the commitment capacity much more than how much a malicious Bob can. And another thing is the impossibility result. We see from the plot here that the capacity expression for elastic channels as well as the compound channels is always positive, but for the UNCs, commitment is only possible for delta less than gamma convolution gamma. So yeah, that concludes the presentation. I have a few references here. And these are some of the publications, 3 of them at conferences and 1 at JSAC journal. And also a part of this work as a part of, has been written in my bachelor thesis. And I got a best bachelor thesis for that in my cohort. Yep. Thank you for that. I'll be happy to take any questions.
If there is any question.
Yeah, so can you go back to the slide? So you're showing that commitment capacity results, right? Even before this. Here, yeah, the one, yeah. So the for the CBSE channel, no. So I'm surprised that the commitment capacity only depends on gamma. Any intuition as to why that happens?
Okay. Hello. The intuition is so we have this condition that gamma and delta are both less than half because they come from that interval. So in a compound binary symmetric channel, it's basically BSC's a BSC gamma plus delta. So a series of channels can get instantiated starting with BSC gamma and ending with BSC delta. The BSC gamma is what you would be most certain about, and if you are most certain about something, then that is not good for commitment. So commitment, unlike reliable communication, requires this noise. Noise is a resource here. So BSC gamma is basically like the least noise thing we can say. And in a compound channel, there is a simple structure. So the delta doesn't matter really. So it looks like the delta doesn't matter because there is no adversary controlling the channel. And what is the surprise is that elastic channels and reverse elastic channels and UNCs have the capacity depending on delta. Does that answer your question?
Yeah, partially, I think. But are you assuming any, in that result, any relationship between gamma and delta, like delta less than gamma, but no restrictions?
Yeah, we have gamma and delta between 0 and half, and otherwise no restriction.
Okay.
We will need for the unfair noisy channel. For the unfair noisy channel, it turns out that gamma convolution gamma should be greater than delta for positive commitment. That's all. Yeah, thank you.
Thank you.
And I'm a PhD student at IIIT Delhi. Here, I'm presenting a paper titled A Measurement Study of TCP and QUIC through the lens of YouTube video streaming. Let's first understand why there is a need for doing this measurement study. So, there are certain conflicting claims about QUIC's performance. For example, in the year 2017, a paper got published in ACM SIGCOMM which says that QUIC reduces the rebuffer rate of YouTube playbacks by 18% for the desktop users and 15.3% for the mobile users. Another paper got published in 2019 in ICIN which says that there is no evidence could be found that video streaming over QUIC and video streaming over TCP result in a different YouTube quality of experience. And hence, this motivates us to study the performance of QUIC and TCP for varying bandwidth, which we commonly observe in the realistic environment. Here, in this plot, we can see that the x-axis is the time in seconds and y-axis is the bandwidth in kbps, where the red lines are the variation in the bandwidth. And hence, our problem statement is finding out whether QUIC always perform better than TCP or they behave same for YouTube videos in a varying bandwidth scenarios. From the related work, there are certain takeaways which are as follows. In the above four papers, we saw that the performance analysis were done in the controlled environment and not in the real environment. Also, in one of the paper, the comparison was done in between the ABR techniques, that is adaptive bitrate techniques over TCP and QUIC. Also, there was a server-side information were known in before. And the last one is that the experiments were not conducted for varying bandwidth scenarios. Before proceeding further, let's understand what is QUIC. QUIC is an alternative to TCP. Here, from the figure, we can see that QUIC is on the top of UDP. Now, the question comes, how QUIC is different from TCP? So there are a number of aspects in which the QUIC is different from TCP. First, there is a faster connection establishment when the server is known before, even within 0 RTT. Also, it has a better congestion control, improved privacy, and a flow control. Not only this, QUIC solves the head-of-line problem by allowing the multiple HTTP streams to share a single TCP connection. QE, that is quality of experience. It is a formula-based metric of Pensieve and MPC paper that we are using to do the performance comparison between the two protocols, namely TCP and QUIC. Now, the approach of data collection, which is as follows. First of all, we have created a list of X videos where X is 47 YouTube videos in our case. And we'll play these videos in a repeated mode. And hence, the total number of videos are 500. These 47 videos were varying from around 55 minutes to 1 hour 40 minutes. The type of videos were like Indian talk show, comedy show, Stanford online lectures, 1960 US presidential debate, and so on. The minimum video quality and the maximum video quality was ranging from 144p to 1080p respectively. We have also collected our videos on different geographical locations, namely Singapore, Germany, Bangalore, and New York. Other than this, we have also collected the data in our lab, which is in Delhi. We have used a trace file to emulate the network conditions. So for this, we have used a traffic shaper called Mahi to emulate the numerous network conditions. So the network scenarios we have emulated are as follows. First is the increasing bandwidth, where it is starting from 128 kbps, goes up to 2048 kbps, where each jump was of around 64 kbps in every 60 seconds of duration. And so on, we have decreasing bandwidth, dynamic high, dynamic low, and dynamic very low. Now, this plot shows a pictorial representation of one of the varying bandwidth, where x-axis is the time in seconds and y-axis is the bandwidth in kbps. Here, the red line depicts the bandwidth variation, which is starting from 1152 kbps and goes up to 640 kbps. And this continues in a cyclic fashion till the time the video ends. Also, we played each video twice in the Chrome browser, once for the quick and then for the TCP. Now, to do the performance comparison, we have formulated certain research questions. The first one is, for adaptive video streaming, does Quick performs better than TCP? For this, we draw a video quality versus time graph, where x-axis is the time in seconds, the left y-axis is the video quality ranging from 144p to 720p, and the right y-axis is the bandwidth in kbps, which starts from 1152 kbps and goes up to 128 kbps. Here, the black lines depicts the bandwidth, the blue line shows the TCP quality, and the red line shows the quick quality. And hence, we can clearly see from this graph that while giving the same bandwidth variation as input, the two protocols are behaving differently. In order to prove this result statistically, we have done a hypothesis testing, where the null hypothesis is that the quick is same as TCP. Alternative hypothesis is quick is different from TCP. We have applied a wedge T test, where h is equals to 0 indicates that the null hypothesis cannot be rejected at a 5% significance level. And the h is equals to 1 value indicates that the null hypothesis can be rejected at a 5% significance level. So from this graph, we can see that around 21% for 21% of cases, the TCP and Quick were performing same. Whereas for the other cases, like for 79% of the cases, the TCP and Quick were different, out of which for 55% cases, the TCP was better than Quick, and for 45% cases, the Quick was better than TCP. Hence, Quick and TCP are different. We further try to find out the reasons behind it, and we further ask certain questions. The first one is, does it depend on the bandwidth change pattern? So we have emulated certain bandwidth patterns like increasing bandwidth, decreasing bandwidth, dynamic high, dynamic low, and dynamic very low. And hence we can see that there is no single winner between the protocols for all these varying bandwidth patterns. Not only this, the percentage of being same are also not constant. For example, in case of dynamic very low, only for 13% cases, the Quick and TCP were same. Whereas in case of decreasing bandwidth, for 62% cases, the TCP and Quick are behaving same. And hence, we cannot conclude. The second question is, does it depend on individual videos? That is, that every time the same video was played and the one particular protocol always performs better. We can clearly see from this graph that this is not the case, and hence we cannot conclude again. The third question is, does it depend on different geographical locations? We have collected the data from different geographical locations, namely Delhi, Bangalore, New York, Germany, and Singapore. From this plot, we can see there are cases when TCP is performing better. For example, in case of Delhi, New York, and Singapore, TCP is better than QUIC. Whereas in case of Bangalore and Germany, the QUIC was better than TCP. And hence, we again cannot conclude anything. The fourth question is, does the backbone bandwidth play a role here? And hence, we play the video without any network emulation tool. And we observe that the video was played at 720p, that is the highest quality. Hence, backbone bandwidth does not play any role here. The future work is to perform a causal analysis to find the root causes and to correlate the network logs, that is the packet traces, with the application layer logs, in order to find out the reason why the two protocols, TCP and QUIC, are behaving differently in a varying bandwidth scenarios. Thank you.
I am Shushmita Mondal, a research scholar working with Dr. Sameerji Kulkarni in the Department of Computer Science and Engineering at Indian Institute of Technology, Gandhinagar. I would really like to thank the entire COMSNET team for giving me this brilliant opportunity to present the paper, a blockchain-based transparent framework for plastic waste management. I would also like to thank the reviewers for their valuable comments, which helped us to improve this paper. This is an outline I would like to follow for the remaining presentation. For the motivation part, we come across many pictures in the internet that shows the polluted tourist space, the polluted oceans, rivers by plastic waste. Plastic wastes are not insoluble in nature. The fishes and farm animals swallow plastic particles and they die. Our drainage system is also clogged by plastics. It is very disheartening to see that 300 million tons of plastic waste is generated per year on Earth, and only 9% of them is recycled. From the plastic waste, if recyclable plastics are handled carefully in a timely manner, the percentage of recycled plastic can significantly increase. There are some organizations who recycle the plastic waste and create some reusable things. Like Ocean Bottle, they create reusable bottles from ocean-bound plastics. Same as the Pluff, also known as the Plastic Flamingo, they create eco-lumber from ocean-bound plastics. These organizations are situated outside India. In India, there is EcoCuddy and there is Recharkha. They basically create handbags, home decors, and many more things from plastic waste. Basically, we want to bridge the gap between the society and these kinds of organizations, and we want to give a small solution for that so that plastic waste can be reduced. The objective of our proposed model is to build a decentralized and distributed application for connecting organizations with people. Now, the participants here can be the shipment company, the organizations, and the users. It is distributed because all of these users have the entire history of the chain in their local storage. It is decentralized because every participants are having every participants are having roles which are not which are similar. The blockchain technology would make this architecture a little more stronger. Let me explain it. Like it is, I am talking about the layered structure here. The application layer here will give the interactive part which every user can use. Below that, the entire thing is in between the blockchain. Basically, blockchain handles the smart contracts. It also handles the incentives by which we can attract more people into our blockchain or into our proposed system. There is consensus layer which takes care of take care of the validation process. The network layer helps to create the distributed peer-to-peer network, and the data layer helps to link the blocks to generate the hashes, etc. Basically, we are proposing a token-based blockchain. We think that it is a little step towards the betterment of the society. Now, why blockchain? As we all know, that blockchain creates a secure database which is linked to its previous block, creating a chain. Basically, blockchain uses SHA-256 hash algorithm and generates hash for every block. So the next block will be having the previous block's hash. It is relevant to say that it is stamped for everyone. Whatever we will change in that block, it will be reflected throughout the entire chain. This linking also helps to track and trace all the data and helps to create the entire history of this block. Blockchain also has very good features that it provides very much transferability. The entire chain is transparent. We also verify and order our transaction through our tokenized consensus mechanism. Basically, we think of two blockchain networks, that is public blockchain, which do not restrict the participants, and there are permission blockchain, which restricts some of the roles of the participants. Closely related work with our system is Plastic Bank and Agora Tech Lab. Basically, these existing systems do not connect a number of organizations with like this kind of work. So we want to raise awareness about the organizations like Recharkha, Ocean Bottle, to engage more people in this plastic waste management system. Another point is Plastic Bank and Agora Tech Lab is situated outside India, and they use cryptocurrencies. But the point here is cryptocurrencies are not very much user friendly. Like common people do not use cryptocurrencies to trade worldly good. But in case of tokens, people can use tokens to buy and sell things. So we are proposing an incentivized tokenized consensus mechanism where the tokens are basically created with some increment with the shipment charges the user will pay to the shipment company. These tokens can directly converted into discounts from the products of the organizations like Recharkha and EcoCurry. This is the structure of our query response based proposed model. So the participants can register to our decentralized application. They will get a unique ID for that, through which they can start to feed in the events to the blockchain. Basically, this is created for an interactive platform. So the validation process is done through this decentralized application. The tracking, the tracing, and the updates are also through this decentralized application. But all the roles are very much distributed in between the participants. Like two-way verification methods is required there, like users and shipment companies for their own transactions, shipment companies and organizations for their own transactions, like that. The incentive mechanism is non-monetary, so it makes the chain a little light, and the block size is smaller due to that. The validation process is also very fast. For the deployment and evaluation criteria, we would like to use Hyperledger Besu because it has Ethereum virtual machine environment for both the public and the permissioned network. So in case of our smart contracts, we'd like to build a consensus mechanism with that, and we would like to design our reward policies with the help of that. Now, we would like to measure the system performances on the basis of amount of successful transactions per second, transaction fee minimization, memory consumptions per block, delay, and mining record. And we would like to compare both the private network and public network performances for our proposed model. Basically, we can't compare related works like Plastic Bank and the Agora Tech Lab because they have not given insight to their blockchain model. As mentioned earlier, it costs less overhead due to non-monetary transaction. It has fast validation, and it is lightweight. Smaller block size of the events, and it can be permitted there, and it can be scalable in case of public blockchain. Basically, the advantage is it is making aware. It is making aware, generate awareness among people having this social issue that we need to manage anyhow plastic waste. Be careful while implementing the two-way validation process, and we need to be intelligent enough to manage so they can be like executed parallelly. In case of conclusion, we have highlighted the social issue, the social cause, and the state of the art of the existing technique. We also proposed our layered model and described that as well. We would like to, and in case of future work, we like to evaluate the performance of our system in public and private network. I would like to conclude with this, that our belief is we have taken a little step towards a better society. That is from my side. Thank you.
Good afternoon, everyone. Today, I am going to present the work on a framework for novel intent detection, COMSNETS 2022. Let's introduce myself. Myself, Ankan Malik. I'm from Computer Science and Engineering Department, IIT Kharagpur. My contact info, ankanem@kgpn.iitkgp.in. Let's discuss the problem we are currently working on. The problem is out of scope aka novel intent detection. It deals with identifying intents that present in the test set, but that were never seen during the training phase. Let's take few examples and discuss it further. The first one, book a table for one at a restaurant, is a book restaurant intent category. Play 30s concerto music on Google Music. It is a play music intent category. Now these two different intent categories comprises the training set. Now at the time of testing, these two intent categories are present. Book a restaurant in Donnelly is a book restaurant intent category. Play some music using Slacker is a play music intent category. But in the testing phase, a new type of intent, read book, is also present. Read this novel 5 of 6. Now, this is unknown intent because this intent was not present in the training phase and it appears in the testing phase. So it requires a tricky algorithm to identify this type of intents in the testing set. Our system able to handle this situation well so that we can detect these unknown intents read book at the time of testing. We can also classify all the intents in the testing set with a good accuracy and F1. So in modern day scenario, intent detection has a huge application in different domains. Let's take the example of a chatbot system. Be it Alexa or Google Home or any other chatbot system. It is feeding 10 million queries per day. And after a certain time, the chatbot used to get new intents, which it has to detect so that in the next cycle, it can able to handle those unknown intent categories. So for example, at time t, will it be colder in Ohio or rate the previous essay 4 of 6 points? These two intents are known to the chatbot system. The first one is get weather and the second one is rate book. But it cannot handle play some music using Slacker, which is add to playlist intent category. So that in the next cycle t plus 1, it can able to detect the play some music using Slacker as an add to playlist intent category. So our goal is to detect out of domain intents. We also want to increase the known intent detection accuracy intents. Earlier, in last 2 decades, researchers are working on this problem in different directions. So let's take the first one, ACNC Moss, which is a 2017 paper by Mew et al., which handles streaming emerging new classes. Scene is another algorithm by Zhu et al. 2020. It is a graph-based network for new level detection. Odin is an algorithm by Liang et al. 2018. It uses softmax probability scores for out-of-domain sample detection. Another algorithm is published recently by Zhan et al. 2021. It proposes energy-based score using a data manipulation framework to generate high-quality OOD utterances with importance weights. In short, it is termed as GOTs. We have used traditional benchmark datasets in natural language understanding system. The first one is SNPs, which was discussed first time in 2018 paper by Kauke et al. The dataset was collected from SNP's personal voice assistant sentences with 7 intent types. We perform our experiments considering 5 intents as known and rest 2 as unknown. The next dataset we have used is ATIS, Airline Travel Information System, 2010 by Tour et al. It consists of audio recordings of people. There are total 5,871 users. Consider 10 intents as known and 7 as unknown. The last datasets we have used is Facebook, which is these utterances have been collected from 3 different domains: alarm, reminder, and weather. There are in this dataset in total 43,323 utterances. We consider 9 intent classes as known and rest 3 intents as unknown. Now let's discuss the approach for novel intent detection in details. We term this algorithm as NID. In the first step, there is a labeled initial data. It consists of examples only from the known intent set. We train a neural model M. So here in SNPs, only 5 known intents are in the training set out of 7. In case of ATIS, 10 intents as known out of 17. In case of Facebook, 9 intents are present in the training out of 12. In the next step, we consider an algorithm to detect out-of-domain samples U dash on the unlabeled data U. Now, after getting the OOD samples, we consider M% of the OOD samples U dash for manual annotation. We experiment with labeling strategy to add the rest of the OOD samples back to the data. Now we retrace test set. So in the next cycle, system able to detect the new intent category. When all 7 intents for SNPs, all 17 intents for ATIS, and all 12 intents for Facebook. We have shown overall accuracy and macro F1 for these 3 datasets. We have also shown 2 different competing baselines. One was SEEN and one was ACNC-MOS. SEEN is a semi-supervised graph-based framework to detect new labels in streaming data. The method consists of a label propagation-based classifier, SEEN-LP, and a novel dataset detector, SEEN Forest. ACNC-MOS handles the problem of streaming emerging new classes. It detects emerging new classes, classifies known classes, and updates the model in streaming dataset. So from this table, it can be seen SEEN and ACNC-MOS are also performing well. But our algorithm NID outperforms them in terms of accuracy and macro F1 for all 3 datasets. To detect with more than 10% accuracy and F1. To conclude the work, we have an end-to-end framework for detection of novel intents. We would like to explore how the models for vanishing intent. We also wish to extend the first domains like finance, and we need to see how do a zero-shot based learning or different meta learning, distance learning. Thank you very much for listening to the talk. If you have any questions, any queries, you can mail me in my mail ID ankanem@kgp, and goodbye.
Hello. Yeah. So thank you so much. Thanks a lot, jury members, Rohit and Navin. Really appreciate. Thank you all the participants for being here. I guess we will just end the session, Ritesh, because we are running a little late. Panel has already started. Thank you. Thanks a lot.
Yeah, sure.